Okay, so we're looking at average rate of change versus instantaneous rate of change. And we started to get the idea of a limit. What was happening as that H value is getting smaller and smaller and smaller. And so now let's get into the kind of the intuitive idea of what a limit is, and then we'll get into more of a precise definition of limits later on. Okay, so what is a limit? So a limit is your Y value. A function approaches from both the left and right side of a given X value. Okay, so when we're looking at limits and we want to write this down, basically the notation is LIM, and then it depends on which variable you're using. So our independent variable is X here. So we have X is approaching some value, let's say A, of a function f of X. Let's say this is equal to L. And so if I'm looking at a graph of f of X, maybe our graph looks like this. And we have some X values, so maybe A is right here. What we're trying to do is, as we're coming in on this graph, on the left and the right of this A value, we're trying to see what Y value is your graph approaching. It might not exist there, but it's getting closer and closer to, in this case, we called it L. So let's look at that in this next example, example 1. So in example 1, you'll notice that those first 3 graphs are almost identical. You have a parabola that's facing upside down. You can see that the vertex is at -3, 4. And so you need to be familiar with this notation. And so what does it mean to say f of -3? And so that's basically, that's asking us, what is our Y value, right, when X is -3? And so if we look at this, to note where -3 is on our graph. So when X is -3, what is Y? So if I look at this, when X is -3, well, that's my vertex, and my Y value is 4. Now, the notation below says the limit as X is approaching -3 of f of X. And so this is where we have to look on the left-hand side of the graph and the right-hand side of the graph. And so the left-hand side of the graph of X equals -3, we want to see what are those Y values as we get closer and closer to -3 on the left. So for instance, -4 is to the left of -3, right? If I look at what is my Y value when X is -4, I would see that I have a Y value of 3. If I even get closer to X equals -3 on the left, so maybe -3.5. If I went up here on my graph at -3.5, my Y value is positive 3.5. Any number that I'm looking at closer and closer to -3 on the left, I see that my Y value is getting closer and closer to 4. And so if that is the same case as what's happening on the right-hand side, so if I'm looking at this coming in on the right-hand side, so X is -2, a bigger number than -3. I hit 3. If I hit -2.5, I'm hitting a Y value of 3.5, getting closer on the right-hand side to -3. I'm getting closer and closer to that Y value of 4. And so I would say that the limit as X approaches -3 of our function f of X is 4. So the graph, the next graph over, is almost identical to the one we just did. The only difference here, right, is there's this open circle on the vertex. And so that is not defined there. And if it asks me what f of -3 is, because that's not a solid circle, I would look above or below that point on the graph to see if there was actually a point there. And there's not a point when x is -3. And so this actually is undefined or does not exist. I'm going to write D and E. But if we look at the limit on the left, we're still getting closer and closer to the y value of 4, even though we never actually get exactly to 4. We get like 3.9, 3.99, 3.9999999. I could go on forever. Not really. And then on the right-hand side, same idea. Even though when x is approaching -3 on the right-hand side, my y value is going to 4. And so this limit, even though the function's not defined at x equals -3, it does exist and it is 4. Okay, so difference with the third graph, almost identical to the graph of the second one, the one we just looked at, except there is a point below that vertex, that open circle at the vertex. There is actually a point, a solid point, a circle, when x is -3. See that our y value is actually 1. So f of -3 does exist in this case and is 1. But limit, let's look at the limit as x is approaching -3. So is the left-hand side and the right-hand side approaching the same y value? If so, even if that y value isn't existing there, if it's approaching the same y value on the left and the right, getting closer and closer to some y value, which it is, the limit exists, and in this case is 4. Okay. So those are just kind of some important points here. So a limit can exist if it's defined there. A limit can exist even if there is no value of the function defined. So x equals -3 is not in the domain here. Or even if x equals -3 is in the domain, but the limit is not going to that value. Okay, so the next graph is a little different. And let me just give you the notation now because it's helpful. So if we're looking at, we can look at one-sided limits. And so one-sided limits is if we're looking at what's happening in the graph if we're just coming in one side of the x value. So if I have, let's say, x limit and then x underneath with an arrow, how about an A, and then a superscript of a negative sign on the top of f of x. So this is the limit as x approaches A on the left. So x equals A on the left. Where if it was a right-hand side limit, instead of that negative sign up here, kind of like a, looks kind of like a exponent, I'm going to write it up here on the top of the page. Superscript of a positive number. Okay. This would mean the right-hand side limit. Okay, so knowing that, that's the next graph, the fourth graph on that page. Notice there's a split, there's a jump in the graph. There's two different pieces of this graph. So when x equals -3, locate x equals -3, and the point on this graph, well, it's not where the open circle is, it's where the closed circle is. So it is defined, and our y value in this case is 1. In order for a limit to exist, the left-hand side and the right-hand side have to be the same value. And so looking at this, if I look at the limit as x is approaching -3 on the left-hand side, as I'm coming into -3 on the left, that's this piece of the graph right directly to the left of that. And so as I'm approaching -3 on the left, we're looking at what the y value is. Is there some y value that we're getting closer and closer to? And there is. On the left, we are getting closer and closer. It never gets there, but it gets close enough. It's going to 4. But if I look at the limit as x is approaching -3 on the right, of f of x, so coming in on the right-hand side using that second piece of the graph, coming down, I'm getting to a y value, getting closer and closer to 1. And since these are not the exact same values, we say that the limit as x approaches -3 does not exist. So let's look at one more. Again, almost the identical graph that we were just looking at. This case, though, the end on the bound on the right at the first piece is open circle, and bound on the left side of the second graph also is an open circle, and we have a solid circle in between those 2 points, open circle. And that solid circle is what is our y value at f of -3, which is 2. Again, though, our limit as x is approaching -3 does not exist. The left-hand side, as we're approaching -3, is also approaching 4. Right, we're going up here, following the graph as x is approaching -3 on the left. The y values we're getting closer to is 4. And then on the right-hand side, getting closer and closer to -3 on the right-hand side, we're getting closer and closer to the y value of 1. Okay, so there is the idea behind limits. Let me just stop the video and start a new chunk.